here, look, it says, let's start at x equals 0 meters. So our position is going to be starting from the origin, okay? Now what we're going to do is we're going to actually find our time axis, and our time axis actually goes right through this 0. So here's my time axis, okay? And if I were to look for how much displacement or change in position it went from 0 to 1 second, right? From 0 to 1 second, let's ask 3 questions again. First of all, which way is it going? Still positive, correct? How is it going? Slowing down. How far did it go? Did it? Positive 3 meters would be the correct answer. Because the area here is 1/2 base times height. So this looks like a positive 3 meters as so. All right. So let's plot that here. So here's my 0. So here's my time axis. And it looks like I don't think we're going to go anything higher than 5, because it looks like this will cancel out, this will get negative, and this stays positive. All right, so we'll make 1 per each block, right? So 2, 3, 4, 5, right? This will be -1, -2, -3. All right. So from 0 to 1 second, we start at the origin, x equals 0 meters. So we start here. Then we move to positive 3. Now, what is the velocity value at 1 second? Raymond, what would you say? Velocity value at 1 second. 0. That is correct. So what should the slope value be at 1 second for the position versus time? 0. And slope value of 0 should look like what? What kind of line?
Straight up and down.
The other way. Horizontal, correct, horizontal. So at 1 second, it should flatten out. That's all I know. So it sort of decelerates to 0, so it should be one of these Johns. Yeah, one of these Johns.
3 meters, not 1.5.
Oh, crap. Thank you. It should be up here. It should be up here. It should be one of these Johns. Right? So notice how it flattens out here. It flattens out here at 1 second. What about 1 to 2 seconds? First of all, which way is it going?
Backwards.
It's going backwards towards the origin, right? How is it going backwards? Is it going at a constant speed? Is it slowing down? Is it speeding up?
Speeding up.
It's definitely speeding up going backwards. Correct. Matter of fact, it speeds up from 0 to 6 meters per second in the negative x direction. So the slope value should be 0, and then you should get negative, bigger negative, bigger negative, bigger negative, bigger negative, so on, right? To negative 6 eventually at 2 seconds, right? So how much distance did it travel from 1 to 2? 3 meters again. So my change in position is negative 3 meters from 1 to 2 seconds. So here, since I'm going in the negative direction for 3 meters, I end up back at my origin. And it starts at 0 slope here, and then it's going to speed up so in the negative direction, so it's going to be one of these Johns. Almost looks like a parabola, right? Upside down parabola. Sounds like a disease, like Ebola, parabola. All right. Now what? Now what? From 2 to 2.5. First of all, which way is it going?
Negative.
Still negative, correct. How is it going in the negative?
Slowing down.
Slowing down. Very good. So at 2.5 seconds, it is definitely what speed or what velocity? How fast is it going at 2.5 seconds? Come on, Mike. I like your purple worm back there.
Thank you. 0.
0, right? Good. So now how much did it travel from 2 to 2.5? Oh, come now. How much did it travel? Somebody.
Negative 1.5 meters.
Thank you. Negative 1.5 meters exit. So, when it travels negative direction at 1.5, it should be somewhere around here. And you know the slope has to be 0 at 2.5. So it's going to flatten out here, right? So it's going to flatten out and it's going to be one of these Johns. Then, what about from 2.5 to 3? Which way is it going? Come on, everybody, together, in synchronous way. Positive direction. How is it going? Speeding up. How much did it go? 1 meter. Very good. So here we have 1 meter in the positive x direction. So it traveled from negative 1.5 to 1 meter. Okay. Like so. And then 3 to 4. How much did it go? Well, I'm sorry. Which way is it going? Forward. Good. So all this, how is it going? Still speeding up. Is it speeding up as much as 2.5 to 3? Or no? definitely not. It's speeding up gradually. How much did it go?
5 meters.
Thank you. 5 meters x hat. So from 1.5, I'm sorry, half, negative half to positive 5, we should end up at where? Good. All right. And it's gonna be a slow, gradual increase. So I'll do one of these Johns like that. It shouldn't be a straight line. It looks relatively straight, but not exactly a straight line. So I didn't use the ruler on that. So what is the total distance the object traveled? The total distance doesn't have to have any direction at all. So all you need to do is just add up all the length traveled in an absolute value way, right? So from 0 to 1, right? So if you add all these up in an absolute value way, you should get something around 13.5 meters. What total displacement did it have? Now they want to know total displacement. So total displacement is when t change in x between 0 to 4 seconds, basically. Okay? So that is equal to x at 4 minus x at 0. That is at 4 seconds, I see it as 4.5. Minus, at 0 seconds, I see 0. Therefore, the total change in position, or the total displacement, is positive 4.5 meters x hat as the correct answer. All right. What about part C? Part C. What was the average acceleration over the time interval from 1 to 3 seconds? From 1 to 3 seconds, the average acceleration is the slope of a secant line. Okay, slope of a secant line. So 1 to 3 seconds. 1 to 3 seconds. You have to find the average acceleration. So find the slope of the secant line. Right? So how do you find the slope of the secant line? So acceleration from 1 to 3 seconds is equal to, right, change in velocity over change in time. Now, change in velocity is velocity at, velocity at 3 seconds minus velocity at 1 second over 3 minus 1. So velocity at 3 seconds, what is that value? Come on. Thank you. Positive 4, right? Meters per second minus velocity at 1 second is 0 meters per second over 3 minus 1. Therefore, positive 4 meters per second over 2 seconds gives you negative 2 meters per second or 2 meters per second squared x hat. Now, some people may say, well, Mr. Kim, doesn't the seconds get canceled out? And answer is no. Why not? Well, if you have meters per second divide by second, that is same as meters per second times 1 over second. Therefore, you get meters per second times second, which is meters per second squared. Little algebra lesson. Yes. Oh, isn't it? Sorry. Thank you. It should be positive. Sorry. Thank you. Positive. Positive 4. It's a positive slope. Yeah. All right. Any questions? Good. Now you need to check your understanding. What I'm going to do is I'm going to assign you pages 3, 4, 5, right? Pages 3, 4, 5, and you should be able to do the multiple choice questions, okay? So you should be able to do pages 3, 4, 5, and multiple choice questions. Some of them you'll see it again. I guarantee it. You know, hint, hint, right? And guess what? Look at this. Ready? Oh my God. Yeah. So yeah, if you want to cheat, I'll give you the answers. So if you want to just go in there and fill in these answers, fine. But you're not gonna do well on the test. But so I would like cover this up, work on it, and check it rather than just like, hey, look at this, I got the answer, and then just write everything down. You know, I'm done. No. And then I guess when do we meet again? On Tuesday? Next week? I'm gonna go over. Are we off Monday? It's Labor Day. Yes, Labor Day. I'm not going to work during Labor Day, Julietta, so you can be here if you want. I'll go over the constant acceleration equations, okay? And then we're going to be doing some like real physics, okay? So, and then we may have assessment during weekend, okay? Because I don't think we have enough time to finish this curriculum if we like have tests during our school time, you know. So we're going to have to sacrifice and have our assessment during the weekend. I'm not going to tell you exactly what time we're going to have the test on, because I know some of you will get the best tutor in main line, and then have your tutor next to you when the time is for the test, and I don't want that happening. Okay, so what's going to happen is I'm going to give you a window of time to work on your test. So when I make an announcement, you would print the test at that time, and you will have to upload your test by certain time, or else done. I know it sounds cruel, but all right. So that's what's going to happen. All right. So I'm going to stop.